everybody, today we're going to talk about balancing chemical equations and the different types of chemical reactions. On the left side of the screen you have all the different equations that we're going to be balancing, and on the right side you have all the different types of chemical reactions. So we've got double replacement, combustion, synthesis, single replacement and decomposition. First of all though, we must balance our equations here. Now when you balance an equation, you basically want to take a very step-by-step method. You want to always go from left to right. The main rule of balancing equations is that both sides of the equation must be equal. So you must have an equal amount of the certain substance, compound or element on both sides, the left and right. So let's start with the first one. It's a pretty easy one. Calcium carbonate turns into calcium oxide plus carbon dioxide. On the left side of the equation, we have one calcium. On the right side, we also have one calcium. That's great. It's equal. It matches. We don't need to do anything to the calciums. Here we have one carbon, and on the right side of the equation, we also have one carbon. On the left side, we have 3 oxygens, and on the right side, we also have 3 oxygens. Here's 1, and here's 2. So, it's actually all balanced. We don't really need to do anything, but for education purposes, I'm going to write 1 in front of each compound. Oops. There we go. On to the next one. We've got silver bromide plus gallium phosphate equals silver phosphate plus gallium bromide. This one is slightly more complicated. We've got 1 silver and on the left side and 3 silvers on the right side. So we need to put a 3 in front of the silver on this side. This could be interesting as I'm not very good at writing on paint. There we go. Onto the bromides. We've got 3 on this side because the 3 affects the bromide as well. If there's a number in front of the whole compound, it affects every single element in the compound. If it's just next to it, like here, it only affects the one that it's behind or in front of. So here we have now 3 bromides on the left side and 3 bromides on the right side. Perfect. Let's move on to the galliums. 1 gallium on this side and 1 on this side. Phosphates, we've got 1 on this side and 1 on this side. So the rest of the compounds just have a 1 attached to them, like so. Alright, the next equation we shall balance is iron plus silver nitrate equals iron nitrate plus Ag, plus silver, sorry. So the first thing I'd like to tell you is that whenever you have a polyatomic ion, which is nitrate, phosphate, sulfate, all of those that have oxygen, you want to make sure that they are considered like an X as one of those elements. So using this method, let's balance the equation. We've got 1 iron on this side and 1 on this side. Great, that all matches up. 1 silver on this side and 1 on this side. Now, the nitrates do not add up, so we've got 1 X on this side and 2 on this side, because as you can see the 2 accounts for the X. So we've got to put a 2 in front of this whole equation so as to balance it. Now this affects the silver as well, so it kind of messes up what we had before. So we've got to put a 2 in front of this silver on the right side in order to fully balance the equation. There we go. And then it's just a 1 on all the others. It's not a very good 1, sorry about that. There we go. Alright, on to the next one. That's sulfur plus oxygen equals sulfate. Or is that sulfite? Not sure. One or the other. Anyways. Here we've got 8 sulfurs, and here we've only got 1. So we've got to put an 8 in front of this polyatomic ion. and obviously it's not going to work with that. There we go. And as you can see, I'm not very skilled at using paint. So now we've got 8 sulfurs on one side and 8 on the other. Let's now balance the oxygens. We've got 2 oxygens on this side and 16 oxygens on the right side, so we must add an 8 to the left side. And this fully balances the equation. Now, the last chemical equation is again a little more complicated. We've got this rather large compound right here, which is actually called acetic acid, but it's got carbon, hydrogen, and oxygen in it. Then we've got acetic acid plus oxygen equals carbon dioxide and water. So again, let's just do the step by step, left to right. We've got 2 carbons on this side and only 1 on this side, so we're going to add a 2 here. We've got 4 hydrogens on this side and only 2 on this side, so let's just add a 4 here as well. Sorry, a 2 there. We've got 4 oxygens on this side because you've got 2 here and 2 here, so that's in total 4. Here you've got 4 here and 2 here, so that's in total 6. So we need to add another oxygen to this side. Let's add it here. Great, this fully balances our equation, and we've finished with all the equations, and now let's move on to the different types of reactions. So we've got double replacement, combustion, synthesis, single replacement, and decomposition. I'm going to give you a quick demonstration of what each of them represent, substituting the elements or the compounds with A and B. So double replacement looks like this. Let me see if I can. Right. So we've got A, B plus D, C equals AC, oopsie, plus DB. Oh, that didn't really work. There we go. Okay, I hope you can understand all this, but I do realise it might be slightly difficult to grasp. Alright, so let's see if we can sort of see this formula take place in any of the chemical reactions we've got on the left. So it doesn't go for the first one. Let's have a look at the second one. Have they switched? So you've got silver bromide here, and then it goes to silver phosphate. You've got gallium phosphate here to gallium bromide. They have switched. So in fact, this second chemical reaction is in fact an example of double replacement, which is great. So I'm just going to draw a line from there to there. Now for combustion. Combustion basically is any chemical reaction that uses oxygen. So it has oxygen on the left side of the equation. So just so we can write this down, let's say we've got AB, oh my goodness, plus O2, which is oxygen, in case you weren't aware, is equal to, well, it could be anything really, BC, I don't know. It's really equivalent to a lot of different things, just going to check in my notes and see if there's anything it is particularly on the other side of the equation, but I don't believe there is. Just checking my notes, as one has to do occasionally. Yeah, it basically produces heat, so it produces different things as well as heat. So let's just have a look at these different equations, and it's pretty obvious which ones produce have oxygen in them, and it's this one. This one also has oxygen in it, but it's relevant for another one, so we won't say that's combustion now, but technically it is. So let's draw a line there, and I'm going to also say this one is combustion as well, because it is. Alright, the next one is synthesis. Now, synthesis is basically what it sounds like. It's a synthesis of different elements. So we've got A plus B equals AB, for example. That is perfect synthesis. And we've got that right here. So we've got sulfur plus oxygen equals sulfate. And as you can see, they're simply synthesized and connected. So I'm going to draw a line from there to there as well. The next one we've got is single replacement. And single replacement is similar to double replacement in the sense that you only replace, well, it's different from double replacement in the sense that you only replace one of the elements. So it looks something like this. AB plus C equals AC plus B. So as you can see, the C and the B have simply been replaced. And you can see this taking place in this, oops, well, it's turned black, which is great. You can see this taking place right here, because the silver and the iron are replacing each other. So the last type of reaction, but not least, is decomposition. Now, decomposition is the opposite of synthesis. You have a compound which is together, a compound, and it separates into two different elements, or two different compounds, as the case may be. And I'll just show what it looks like. 2A plus B. And the last one that's left on the left side is calcium carbonate turns into calcium oxide plus carbon dioxide. So it's that one. There we go. Now, I know this looks a bit messy, but I hope you've been taking notes and can follow along easily enough.